before starting the software, I will a small PPT. Basically, I want to explain the workflow of the software. Okay, so for that, I will show you this page. Here it is. So that is the workflow of the structure analysis software. That is the STAAD. So एक्चुअली अगर मैं बात करूं तो ये एक मैनुअल प्रोसीजर जैसा ही है. लाइक इफ यू वांट टू क्रिएट अ बिल्डिंग ऑन साइट, then the thing will be we have to calculate everything on paper. Okay, so ये सारी चीजें हम लोगों को पेपर पे आपको कैलकुलेट करनी पड़ती थी, बिकॉज आफ्टर ड्यूरिंग द जब आपका वर्क प्रोग्रेस में होगा देन यू कांट चेंज थिंग्स. ओके, सो हम लोग क्या करते हैं कि मैनुअली पूरा एक प्रोजेक्ट करते हैं. दैट इज द कि हम लोग प्रोजेक्ट को मैनुअल पूरा क्रिएट करते हैं. सेम थिंग विल हैपन ऑन द सॉफ्टवेयर. तो जैसा जैसा मैनुअल स्टेप्स हमारे आपके मैनुअल कैलकुलेशंस के रहते हैं, सेम थिंग विल बी डन ऑन द सॉफ्टवेयर. लाइक वी हैव टू एज्यूम अवर स्ट्रक्चर फर्स्ट. जैसे कि पेपर पे भी आप यही करोगे कि आप यू हैव टू find out the number of stories of the building and position of the column and beam and all everything that a structure will carry out like load and all. तो ये जितनी चीजें भी होती हैं वो सब आप क्या करते हो, मैनुअल कैलकुलेट करते हो. सेम थिंग we create it on the software. So the first thing is we have to create a virtual model, that is a prototype model. Okay, so in the software जो सबसे ज्यादा टाइम टेकिंग आपका जो प्रोसीजर होता है दैट इज द मॉडल को क्रिएट करना. फर्स्ट थिंग, like how we create a prototype model, that will be a, a task that will take too much time. इसी में आपका टाइम लगता है, because applying property load and all that is a simple concept. बहुत आसान रहता है, एक सिंपल क्लिक से ही सारी चीजें हो जाती हैं. बट क्रिएटिंग मॉडल लाइक कॉलम की पोजीशंस, लेआउट डिजाइन करना, डिसाइड करना, देन उसको कैड से आपको देन इंपोर्टिंग इट फ्रॉम द कैड टू द ऑटो कैड टू द स्टैट प्रो, इट विल टेक. ओके, सो देन जब आपने एक मॉडल को क्रिएट किया लाइक यहाँ पे जैसा कि मैंने बताया, सो इट विल बी अ वायर फ्रेम मॉडल. जो भी आप मॉडल क्रिएट करोगे दैट विल बी अ वायर फ्रेम मॉडल. नेक्स्ट थिंग विल बी वी हैव टू अप्लाई प्रॉपर्टी. सो अंडर द प्रॉपर्टी बेसिकली वी आर गोइंग टू असाइन शेप, मटेरियल. ओके, शेप एंड मटेरियल. लाइक शेप में कॉलम में बी ऑफ अ सर्कुलर और इन शेप ऑफ रेक्टेंगुलर और इन, एंड सेम थिंग बीम कैन बी ऑफ ट्रेपेजोइडल शेप. ओके, so कैसा शेप है उसका, देन आफ्टर दैट व्हाट इज द थिकनेस एंड ऑल, एंड नेक्स्ट थिंग material. Sometimes in that we have steel shapes also, but steel में जैसे like मैंने कॉलम प्रिपेयर किया, that can be of a concrete or of a steel also. अब स्टील में हम लोगों का स्ट्रक्चर वाला जो पार्ट होता है दैट इज उसमें हम लोग एंगल्स एंड ऑल जो भी आपके स्टील शेप्स होते हैं आईएस कोड के अकॉर्डिंग, सो आप उनको यूज करोगे. बट समटाइम्स अ सॉलिड रॉड. ओके, ये चीज भी हमारा क्रिएट किया जा सकता है थ्रू द सॉफ्टवेयर. और उसके बाद में आगे के प्रोसीजर्स आपकी जो भी एनालिसिस वाली चीजें रहती हैं. तो हमारा पहला स्टेप जो हम लोग आप फर्स्ट सेशन में कवर अप करेंगे दैट विल बी अ कंक्रीट स्ट्रक्चर. तो मैं उसी पर फोकस करता हूँ अभी. तो आफ्टर क्रिएटिंग अ वायर फ्रेम मॉडल, नेक्स्ट थिंग विल बी अप्लाई प्रॉपर्टी एंड नेक्स्ट थिंग विल बी अप्लाई सपोर्ट. इन केस ऑफ बिल्डिंग स्ट्रक्चर्स जो कि हम लोगों को फिर आज पे फोकस करना है, वी हैव टू असाइन सपोर्ट्स ऑन बेस. आपको ये बेस पे असाइन करना है. बट समटाइम्स कुछ केसेस होते हैं लाइक ब्रिज हो गया या आपके कंडीशंस ऐसे होती है जहां पर आपके हम कह सकते हैं कि मूविंग लोड्स वगैरह रहते हैं, तो जहां पर स्प्रिंग सपोर्ट वगैरह देने होते हैं, तो ये आपके पॉइंट्स आपके बेस से भी डिफर कर सकते हैं. कि ऑलवेज बिल्डिंग के केस में तो नॉर्मली आप बेस पे दोगे, बट ब्रिज हो गए इन सब केसेस में हम लोगों को सपोर्ट बेस के अलावा टॉप पे भी देना पड़ सकता है. अलोंग द बेस वी हैव टू असाइन इट ऑन द टॉप ऑल्सो. तो ऐसी कंडीशंस के लिए हमारे पास डिफरेंट डिफरेंट सपोर्ट्स रहते हैं दैट which I will explain in the support option. Then after this we have to assign load. अब बात करते हैं लोड की. So here basically we have two types of load only, dynamic and static. Okay, a same thing will be आपका analysis होता है, like there will be a static analysis and dynamic analysis. Dynamic means the load which is varying according varying, जो आपका लोड वेरी करता है लाइक वाइब्रेशंस हो गए आपके. नेक्स्ट थिंग हो गया योर earthquake loads हो गया, and your wind load, that is a type of dynamic analysis, क्योंकि आपका इसमें इसमें लोड में फ्लक्चुएशंस रहते हैं आपके, एंड मूविंग लोड आल्सो, लाइक अगर कोई व्हीकल आपका मूव कर रहा है, दैट इज आल्सो अ टाइप ऑफ डायनेमिक लोड, एंड स्टैटिक लोड विल बी अ टाइप ऑफ सल्फेट ऑफ स्ट्रक्चर दैट विल बी रिमेन्स इन कांस्टेंट पोजीशन, ये आपका फिक्स रहेगा, मूविंग कंडीशंस में नहीं रहता है। एंड लाइव लोड को भी हम लोग एक तरीके से एक स्टैटिक लोड में लेते हैं, लाइक लाइव लोड ड्यू टू द ह्यूमन बीइंग, क्योंकि वैसे तो हम लोग उसमें आप वेरी सक्सेस पे अपने फ्रेम पे आप इधर से उधर आप मूव कर सकते हो, बट ये मूवमेंट आपके वाइब्रेशन जनरेट नहीं करते हैं बहुत। ओके, दैट्स वाई लाइव लोड भी हमारा एक तरीके से एक स्टैटिक लोड के अंडर ही आपका ये आएगा। सो जब आपने ये सारे प्रोसीजर कंप्लीट किए, सो नेक्स्ट थिंग विल बी वी हैव टू डू प्राइमरी एनालिसिस। सो अंडर द प्राइमरी एनालिसिस actually we get only shear force, sorry, we will get axial forces result, and बेंडिंग मोमेंट डायग्राम्स, ये सारी चीजें आपको प्राइमरी एनालिसिस के थ्रू मिलती हैं, और इन सब चीजों को हम लोग चेक कर सकते हैं अंडर द पोस्ट प्रोसेसिंग। सो बेसिकली पोस्ट प्रोसेसिंग जो रहता है, इट विल शो यू द रिजल्ट इन टू फॉर्म्स। first will be your graphical representation and tabular report। ओके, ग्राफिकल मींस कि अगर बीम पर आपका बेंडिंग हो रहा है तो उसका डायग्राम आपको ये शो करेगा, दैट इज द ग्राफिकल। एंड टेबल में वो आपके हर एक बीम पर जितने भी आपके स्ट्रक्चर्स में रहेंगी, उसमें जो बेंडिंग हो रही है, जो एक्सेल प्रोसेस लग रहे हैं, उसकी वजह से जो उसका स्ट्रक्चर का रिस्पॉन्स है, वो सब चीज़ों की, इन सभी चीज़ों की एक टेबल भी क्रिएट करता है। एंड एवरी ये सारी चीज़ें हम लोग देख सकते हैं पोस्ट प्रोसेसिंग में। देन नेक्स्ट थिंग पोस्ट प्रोसेसिंग के बाद है सेकेंडरी एनालिसिस। सो फ्रॉम द सेकेंडरी एनालिसिस, like if it is a concrete structure, so to get the concrete detailing and reinforcement detailing, we have to do secondary analysis। अगर स्टील स्ट्रक्चर है तो उसके लिए भी आप लोग सेकेंडरी एनालिसिस के थ्रू ही स्टील डिटेलिंग करेंगे अकॉर्डिंग टू द कोड्स, जिस भी कंट्री का कोड आप यूज करना चाहो। सो दिस सॉफ्टवेयर स्टैड सपोर्ट्स मोर देन 90 कंट्रीज एंड कंपनीज कोड। आपके ऑलमोस्ट 90 कंट्रीज कोड को ये सॉफ्टवेयर सपोर्ट करता है। सो एंड ओरिजिन जो सॉफ्टवेयर का था दैट इज द यूएसए, तो इसमें आपको लोड केसेस जो आपको मिलेंगे यूएसए बेस एंड आईएस कोड्स, इन सब चीज़ों पे आपको लोड केस मिलेंगे। सो नाउ मैं डायरेक्टली सॉफ्टवेयर पे आता हूँ। लेट मी शो यू द स्क्रीन ऑफ सॉफ्टवेयर, हियर इट इज। So whenever you open up this software, our first thing will be to change set it according to the IS code, because जैसा कि मैंने भी बताया था that this is a software that USA based software आपको एक कंपनी बेंटली कंपनी, सो इन्होंने जो सॉफ्टवेयर का सेटिंग है डिफॉल्ट सेटिंग से, दैट इज FPS यानी फुट पाउंड इसमें आपका रहता है। सो वी हैव टू कन्वर्ट इट अकॉर्डिंग टू द मेट्रिक यूनिट। सो जैसे आप सॉफ्टवेयर ओपन करेंगे, यू विल सी दिस स्क्रीन। यहाँ पर आपने जो भी रिसेंट प्रोजेक्ट किए होते हैं वो आपको यहाँ पर दिखते हैं। ओके, एंड कॉन्फ़िगर, यहाँ पर जो आपका ऑप्शन है फ्रॉम दिस ऑप्शन कॉन्फ़िगर वी चेंज अवर यूनिट। सो बेस यूनिट डिफॉल्ट इट विल बी इंग्लिश। सो व्हेनेवर यू यूज दिस सॉफ्टवेयर फर्स्ट टाइम, वी हैव टू चेंज द बेस यूनिट टू द metric, एंड ग्लोबल एक्सेस शुड बी YF। यू कैन चेंज इट टू द ZF ऑल्सो, कर सकते हो, बट लाइक ट्रेडिशन सा है कि ना इस सॉफ्टवेयर पे काफी टाइम से एवरीथिंग वाज अलोंग द YF, सो प्लीज डोंट चेंज इट टू द Z। मोस्ट ऑफ द पीपल वर्क इट, जो इसमें वर्क करते हैं वो YF पे करते हैं। लाइक इन द AutoCAD यू नो दैट वी हैव X एंड Y ऑन द सेम प्लेन एंड Z उसके अपोजिट होता है, बट हियर इन केस ऑफ STAAD X and Z will be on same plane and Y will be the its normal direction। जो normal में आपका थर्ड एक्शन में जो आपका रहता है 3D का, वो that will be Y up। So don't change it and click on OK। So I already changed it the base unit to the metric, so you also have to select it metric, then click on OK। So now our unit is changed to the metric। जो लोग सॉफ्टवेयर पहले से भी यूज कर रहे होंगे उनके पास एक ऑप्शन भी रहता है कि दे कैन से कि वी कैन चेंज द यूनिट फ्रॉम हियर आल्सो। लाइक आप इसको मत करो कॉन्फ़िगर से, यू कैन गो टू द न्यू एंड चेंज द मेट्रिक फ्रॉम इंग्लिश टू मेट्रिक, बट ये क्या रहेगा कि पर्टिकुलर उस प्रोजेक्ट को ही चेंज करेगा And next thing, whenever you use the structure wizard and all, and even if you provide the property in terms of and all, still software will convert it and show you in the table in fps. That means कि आपका ये footage में आपका show करेगा. Okay, so that's why you have to change it from the configure. Don't change it from here. ओके, मोस्टली पीपल यही करते हैं जो लोगों को सॉफ्टवेयर पे स्टार्ट करते हैं फर्स्ट टाइम पर. उनको लगता है कि यहाँ से डायरेक्टली न्यू पे गए, देन जस्ट क्लिक ऑन द मैट्रिक एंड यूनिट विल बी कन्वर्टेड. नो, if you click on the metric from here and then you provide the property like 0.23 by 0.23 in sorry, in meter, that will be 230 then software will convert it to the inch and it will show you like 9 inch. Okay, so वो अपने आप कन्वर्ट कर देता है. और ड्राइंग को रीड करने में, आउटपुट को रीड करने में आपको प्रॉब्लम होगी. ओके, नाउ
Mr. Amit,
यस मैम.
little request. We have participants from all over India, so some may not understand Hindi.
Okay, okay ma'am, so I will.
Thank you so much. Thank you.
Yeah, okay. So now after this, next thing will be we have to provide we have to give file name like if you are, yeah, so you have to provide every time a unique name, because whenever you provide file name to the structure one, default it will be structure one. And also in the your location file there, if there is a structure one file already, then it will replace the last one. That's why every time you have to provide a unique name here. Okay, so like I'm just going to provide a unique name like day one, and also I will type the date also because I already create. Okay, now next thing we have to provide the location. So I just change it to the D drive. Don't save your file on desktop or in the C drive, because whenever if your window get crashed, then your all the old work will be deleted. So that's why I just create a new location other than the your C drive. So I just save it in the D drive and I create a folder first in the D drive, then I select it through the browse option. Okay. So default it will be in the C drive. So you have to create a folder in any other drive. Then we have to select it. Then click on the create here. So now here it is, your software working workspace. Okay, so I'm just going to explain the software's GUI, that is the graphical user interface. So for this I have to show the PPT one more time. So here it is the workflow. So our first step was prototype model, how to create a prototype model. So to create a prototype model, we have geometry menu. Okay, so through the geometry menu, we can create our structures. Like here we have many tools, grid option and structure wizard, translational repeat, and all. So all these tools will help you to create your virtual model. And then after creating it, if you want to view your model for any update or any for any other changes, we can see it from the different view through the view menu. Like I'm just going to create a structure through the structure wizard first. I'm just going to create a random structure. I will explain it later how I created it. So everything I will explain it later. Just let's see it. So here it is. Okay, so this is our model. So I want to see it from the top, then go to the view menu, and here we have different views. So first will be your isometric view, next thing is your top view. So when I click on the top view, so now I'm able to see this from the top. And here next thing is the bottom, same thing if I want to see it from the left side or from the front. So we have different views option. Next thing, we have a select menu. So you know that under the structure we have different type of entities. Like in the structure we have beam, column, slab, and Also we have nodes. Nodes means joint between any two beams. Okay, so we have nodes also. So in the STAAD we have different type of entities. So to select these different entities, we have different type of cursors. So if you want to select a node cursor, then we have a node cursor option here. So just go to the node cursor. Now I am able to select the node only. Okay, that is the joint point. Okay, same we have a beam cursor. So using the beam cursor, your default cursor will be beam cursor. Okay, so through the beam cursor we can select the beam. Next is the plate cursor. So using the plate cursor, we are able to select the plate. Plate means slab. Okay. In this software, we know the slab in terms of plate and element. Okay. So right now I didn't create any plates. That's why we can't select anything here. If I create a plate, then to select that particular plate, we have to use plate cursor, and we have the solid cursor also to select the solid. And different type of cursors are also here, like a geometry cursor. So using the geometry cursor, we can select all the entities as a single time. Like through this, we can select the beam, slab, and all. Okay. Now after creating after these tools, next thing was in the workflow, next thing was apply property. So for the property we have a specification menu. One more thing, we here in the software we have two menus. That is the primary menu at the top, and here it is the secondary menu also. Yeah, you can see the secondary menu. So if I click on the property here, then you can see we yeah, so when I click on the property, you can see, so here specification is also selected. Okay, so under the specification, in the main menu under the specification, we have property, material, and support option. Okay, so when I click on the specification, here it is the here it is the properties option, like mean what is the shape of our beam and all. We can assign the shape through the beam profile, and also we have plate profiles. The next thing is the prop material, how to provide materials and all. And then support, like a pinned support or fixed support, everything you can see in the specification. But in the secondary menu we have different tabs here. Like through the properties, we are able to provide properties only, then go to the material to provide the material and specifications. So under the specification, we have if I want to provide any offset to any member, and or I want to create a floor diaphragm and all, so that can be create. If you want to provide a tension or compression property to any member, then we have a specification menu. Okay, then support. Okay, so that means here property, material, specification, and support, all these four tab is are also available in the specification main menu. Okay, then next thing is the loading. So under the loading, we have load case detail option and we have definitions option. So through the definition, that means for the dynamic load like earthquake, wind, moving load, we have to give definition first. Okay, so if I maximize the definition here, we can see vehicle definition, time history definition, wind definition, snow, seismic reference load. So all these can be defined. That means, like if I want to do earthquake load check for any structure, so we have to provide few parameters, like uh, under which zone our structure is going to be create, and type of the structure, like if it is a brick infield or any other material, and if it is a normal resisting frame building or any special momentum resisting frame, that is the SMRF or OMRF, that is the ordinary moment resisting frame or of special moment resisting frame. Everything will depend upon the your type of concrete. Like if it is M20 less than M20, then it will be a type of ordinary moment resisting frame. And if it is, and if your concrete grade is like M20 or M25, then it will our structure will known as a special moment resisting frame. So according to these values, we have different response reduction factor. Okay, so all things will be defined through this seismic definition as MRF, that is the moment resisting frame, your zone factor, your type of soil, and your type of support, and your type of foundation. So under which foundation your on which foundation your structure is going to be prepared, everything we have to define through the definition. And after this, we have to give this load, we have to add this load through the load case details. Like under the load case details, we have different type of loads, like you can see a dead load, live load, true load. That means every load, after defining the load and all, we have defining, after giving the definitions, we have to add that load through the load case details. So that may I want to say, from the definition we are going to add only the definition, but that definitions will be assigned on the our structure through the load case detail option. Okay, and here we have dead and live load also option also. I will create a structure, then I will explain these things also in that particular structure. Okay, after this, after providing this load and all, our next thing will be do a primary analysis. Okay, so after providing primary analysis, next thing is our post processing report. Okay, so first I'm going to open a recent project here so that you can see which type of work we can do. So that is a structure, and I just suppose this building was situated in Shillong, that is the seismic zone 5. Okay, I will create a manual structure also. Right now I am just going to show the post processing results. That's why I open a pre-created structure. Okay, I will create this type of structure one more time manually, so that you can get how we can create it. Okay, so after creating this virtual model, next thing was property. So when I go to the property, here I define two types of that is for the column. Whenever I click on this property, that is the rectangular zero point 0.5 by 0.45, that is, here we can see the columns as in red color. That means these properties for the column. Next I just add it. Now you can see the beam in red here. So now this is for the beam, and this is 0.45 by 0.4. Okay, next was your support. So I just create a fixed support. You can see the following support cannot be editable. We can see the symbol here. So this is your fixed support. Then come to the loading. So here I provide the seismic definition first. Like here, zone is 0.36. If I click on the edit, so you can see zone was 0.36, and response detection factor is RF. RF means RF is 5. That means it is a SMRF, special moment resisting frame. That's why the response reduction factor is 5. If it was OMRF, that is the ordinary moment resisting frame, then the RF value will be 3. Okay, importance factor is the 1. That means, like if it is a residential building, so it importance factor will be 1. If it is a commercial or any office, then it will be 1.2. And if it is an important building, like a school, college, where people gathering is more, so it the importance factor will be 1.5. So according to our type of structure and type of building and type of it's used, like residential or commercial or any important building, so importance factor will have different values, 1, 1.2, and 1.5. Then rock and soil side factor, SS, is 2. So 2 means it is a uh, soft soil. Okay, yeah, we can see, sorry, it is a medium stiff soil. Okay, then type of structure, that is MRF. Then damping ratio, that it is a constant value. Damping ratio for, according to the IS code, will be fixed. It is 5%. That will be 0.05. And period in X and Z, it has been calculated using the formula. Okay, so So everything you can see we have to add through the our structure. Zone value was 0.36, means it is in the zone 5. If it was your zone 2, then the zone factor will be 0.1. So these value added will be added by us. हम लोग इसको add करेंगे, okay? And after that, floor weight, like what is the dead load, live load, and all, everything has been added. Everything is defined by the definition. And after that, after giving this definition, next thing is our load case details. So first was earthquake along the x-axis, then earthquake along the z. Here you can see that is from the x-axis. You can see the x direction will be from left to right, or we can see it from the this coordinate also, x, y, and z. Same if you want to see it from the z, so here it is from the z acceleration. Then it was dead load also. I defined the dead load and live load also here. That is the floor load. Then load combination. And next was we have to do analysis. So I'm just going to show the analysis output. I just created this structure last day. Okay, so here I was doing the concrete design. Sorry, I was doing the earthquake load check. Okay, so that's why we have to check the story drift. This command is added by us. From here, I'm just going to show you. So under the analysis, we have post processing command, then define command. So here we have story drift options. So I just add the story drift here, 0.004. So that is the diff value. Then when I analyze it, we will see the output here. So first thing, this is the output. So we will get the output like this. This is uh, a PDF format. We can create convert it in the PDF format. This is the table. We can see it is a tabular report also. But to see the graphical report, we have to open the post processing. So here we can see the output. These are the output values. That will be the base year value and all. It's calculated by the software itself. We can calculate it manual also, but it will take too much time to calculate these values manually. Then at each level, what is the axial forces? This is also created by us. So like let me show the axial force value. It is at the level of 7 meter height. The total axial force was this one. Then at the height of 10.6 meter, this is the total axial load. Everything is calculated by the software. Now I will show you the post processing here. So under the post processing, we can see the tabular report and also the graphical report. Okay, like if you want to see the beam results, so that is the bending moment about z axis. So this is the graphical representation. And at the right side, we can see the tabular report of the beam end forces. Okay, if maximum bending moments values and all due to the earthquake load and all, everything you can see through the table also. So by the post processing, we can do primary analysis. We can see the graphical report at the left side, and at the right side we will see the tabular report. Okay, so now I'm just going to create a structure from the scratch so that you will be able to understand the software properly, because I know everything up to this point you didn't get anything right now, because I just opened a complete project. Okay, so I'm going to create a project from the scratch. Okay, yeah, let me check. Yeah, if Sant Gupta, yeah, you can ask your question if you have any doubt.
Good morning, sir.
Yeah, good morning.
You are describing this STAAD software on STAAD version, I think,
Yeah.
isn't it? I have STAAD V8i. So, will it make any difference, or the things will go easily?
There will be only a GUI difference, and working procedure will be same on both software. Because
Okay.
and next thing, there is a problem in the V8i. Like in the V8i, we don't have the current IS codes. Like we didn't get the IS 1893 2016 amendment. Under that, you will be get only the 2015 part 3 options. But right now we have 2016 part 1. that is the IS latest code. So you will not able to use the latest code. And also in the V8I version, if you do the wind analysis, so we don't have the IS 1875 codes, because and let me show you.
Uh,
Here it is. So we don't have the IS code for the wind analysis in the V8I version. We have it in the latest version of STAAD only. Okay.
can
And
you guide to means is there any trial version or something to download this statpro.connect version?
yeah, for this you have to contact Bedi sir or yeah, Himi ma'am, because I
Okay,
don't have any
okay, sir.
idea about this. Okay.
Okay, thank you.
So so I think someone more Anuj. Yeah, Anuj, you can ask.
Yeah, so good morning, sir.
Yeah, good morning, sir. Good.
Yeah, sir, I have one question that can we able to perform the SSI in this software, particular for the by providing the different layers for the foundations point of view for any structures?
I didn't get it properly. Please explain one more time.
Yeah. Now is it clear?
Yeah, yeah.
Yeah. My question is, can we do the SSI soil structure interactions by in the
Uh,
of by providing the different layers of soil layers for the foundations point of view?
Now, actually, sir, in this software, we have in the foundation design, we can create only reinforcement detailing, and you are saying that like SSI detailing and all. We only provide soil bearing capacities value. Okay.
Okay. Yeah, but in that we can whatever the soil bearing capacity it is we can consider normally the designers are considered as a fixed condition, right? The foundation we are assuming it's a fixed, but in actual it is not fixed. It is in the flexible conditions.
Yeah, obviously, sir. For that, that is the software. We have software limitations, like there is only input options,
Yeah.
so we have to provide values according to the available input options only.
Okay, fine. Thank you.
Okay, so just going to create. Okay, so here it is your software. Okay, let me explain. So yeah, so basic point of the base point to create a structure is that is the coordinate system. Like we can create our structure through the coordinate value also. That means we have to create each node one by one by providing its coordinate value, but it will take too much time to create your structure. Like I just create a 000 node. That means this node is at the 000. That is the coordinate value of the software. Next, if next node is at the 500, then next point will be at 500. Then I want to create a beam between these two nodes. Then we have to provide the node number. So node here, to show the node number, we have shift n. So here we have node number 1 and 2. So we have to type the value node number 1 and 2. So now there is a beam in between these nodes. Like next node is at 0, 5, then next thing at 5, 5, 0. Okay, now I want to create a diagonal beam between 2 and 3, so we have to type 2 here and 3 here, but this will take too much time to create your structure. So that means this option will used only when we have to modify our structure, or we have to see the output. Like if in the last, if you are getting an error, like your beam number 2 is getting failed, so in your complete structure, find out the exact position of the beam number 2 will be selected using this option. Like if I click on the 2, you can see the beam number 2 has been selected. So this option will only help you to modify your structure or to rectify the your errors. So that means we will not use this option to create our structure. Next thing, yeah, if you select all this, you we can see we have right now we have the beam cursor. That's why only the beam will be selected. And if I delete them, so it will say deleting beam has left some node. That means attached entities like node will ask to delete them also. If I click on the S, so you can see the node has been also deleted, but there is a single node remains because we didn't select that particular node. So to select this node, we have node cursor. So I just I just customize my uh, quick access toolbar. I just added few tools like view tool and all here, so that I'm able to select them. Okay. So next thing, we have translational repeat option and structure wizard option. So I'm just going to create a regular structure through the structure wizard. If your structure is in the regular shape, that means all the columns are aligned, and then we can use the structure wizard directly. Like I'm going to show you an assignment for that. Let me open. Yeah, here it is. This is the front view of your structure, and this is the top view. You can see here all the columns are aligned in same direction. Okay, and also the beams are aligned. Then we can create it through the structure wizard. That will be very simple option. Okay, but if your column are not aligned, in that condition we have to import our model from the from the AutoCAD. Okay, so just see here, let me note few values. Like along the top view here, it will be your x-axis. Okay, and this will be, just 1 minute, and this will be your z-axis. So along the x, it software will call it as a length value. So total length is 3435 15 meter. Okay, and the divisions are 3, 4, 3, and 5. And along the width, it is 444, that is the total 12-meter length, 12-meter width. And along the height, there are total height is 18 meter. Okay, you can count it here. It is the height, that is the front view. You can see it from the front view, 34443. Okay, and the division along the height was 3, 4, 4, 4, and 3. Okay, I just noted down these values. Now I will create it directly through the structure wizard. Okay, so I will go to the structure wizard option here, and here we have different type of prototype models. Like if you want to create any truss, then we have different type of truss like hoe roof, hoe bridge. Like I just, if I put the hoe roof, you can see total length of the roof, this type of truss is 50 meter, height is 10 meter, width is 10 meter, division along the height is 15. So you can change this value according to your requirement. Like if our length is 100 meter and total divisions was 10, and width was, okay, so width was 15 meters. So just you can change it according to your need. So that is the type of test. It is created by the structure wizard directly. Okay, here we have to create a building frame model. So that's why we will pick the frame models. Also through the structure wizard, we can create circular plate and all through the surface plate model option. Here we have a cylindrical surface option also. Just like I want to create it along the y-axis, so we have to change these parameters. I want to, if you like, you want to create any chimney type shapes, the total height of the chimney is 50 meter and radius is of 10 meter. So you can create it according to that also. Okay, so this is a shape. So this can be create by the software itself through the structure wizard. And then after creating it, we have to transfer it to the STAAD Pro, because it right now it is in the structure wizard menu. Okay, so just to transfer it to the STAAD Pro, either you can close it directly, then it will ask to transfer, or we have a transfer model symbol here. Through this we can transfer it also. Right now I'm just going to create a frame model. So I will go to the frame model here, and I will pick a bay frame. Bay frame means the frame which base is open. Okay, so according to the assignment, the total length was 15 meter. So I will provide the length value to the 15, height was 18 meter and width was 12 meter. Along the length, total division was over 4. So here total divisions are 4, but this this divisions will be divided in equal intervals, like you can see it of 3.75, 3.75, but we have to change it according to our need. So it was 3435. Okay, so I will type first value of will be 3, then 4, 3, then 5, and click on OK. Height was 15, division were 5. Okay, but total the value was first was 3, then each was 4, and last one was 3 again. Then width was 12, but the division were 3 here. Okay, so we have to change the number of divisions, that is the number of base along width was 3, and these were 4 meter each. So it will be like this. Okay, no need to change this value because it will be created in the equal interval. Then click on apply. So here it is, our model has been created in the structure wizard. Now we have to transfer it to the STAAD Pro. So I just said either just close it or click on this symbol. Okay, so like I'm just going to close it. So when you close it, it will ask, would you like to transfer or merge your model into the STAAD Pro? So obviously you have to click on yes. Now it will ask the exact position where you want to place it. Like if you want, if it was a plate, then we have to provide the height at which you are going to place it. So right now this is a building structure, so I'm just going to place it at origin, so no need to change this value. But if you want to change the position, like you want to place your structure along the x-axis at a distance of 5 meter, like if there is another structure at the origin, then you do, and you don't want to overlap them, then you have to change this value from here. Okay, so I'm not going to change it because there is no any other structure. Okay, so this is our model which has been created by the software. Same, if you want to import any other model, then we have an option import and export. But this time we have to import the file from the AutoCAD. Okay, so go to the import and export. Then here we don't have directly DWG option. We have to convert our AutoCAD file into the DXF. In the AutoCAD, we have an option to convert the file into the DXF format. Then click on the DXF. I will just save it. Okay, with the name of, yeah. Now you have to pick the exact position, like just wait. I have a project files, 3-story building. Yeah, here it is. Okay, I'm just importing a CAD file, AutoCAD file here. So that is the structure file. So this plan was created in the AutoCAD. Now using the stat structure, sorry, using the transition repeat, I will create another flow. Okay, so I have to select this structure, then I have to use translational repeat option. I want to create G plus 3-story building. Okay, so go to the y-axis, number of step to the 3, then each floor height. Like if it is at a height of 3 meter each, so just type 3. But if your floor are at different height intervals, so you have to change the spacing from here. Okay, and like our first floor was at a height of 3.2 meter and others were at of a height of 3 meter. So first floor was at a height of 3.2 meter, and we have to click on link step, then okay. Sorry, I just forget to in the direction. Sorry. So structure wizard, then we have to change the global direction to the y because it will be along the top. No, the y will be along the top. That's why change the three number of step three, then change the value to the 3.2 meter each. Just link them and click on OK. Yeah, I think yeah, here it is. That was a graphical error only. That's why it was seeing like it was along the x-axis. When I click on the isometric view, it is clear now. But creating it will sometimes will create few extra columns. Like here, we have two columns at a distance of only 0.15 meter. Obviously, that will okay. So that means now we have to select them any one of them and delete them. अब ये कैसे करना है? That will be according to your project. Okay, so कि कौन सा आपको delete करना है? You have to select that particular column and then you have to delete them. Okay, same you have to select them because every node will be connected by that particular method. Okay, so next you have to provide property and all. So that is the procedure of creating your model through the AutoCAD also. So we have few other options also, but you know that in a very short time I can't define all options. Okay, so going to create a regular model here. Same model again. Length was 15 and it was like 3, 4, 3, 5. Height was 18 and it was like 3, 4, 4, 4 and 3. It was along the 3. Apply it, transfer it, yes, okay. Now next thing is the property. So length value is 3 meter. Okay, so for the property, if we have to create a property for the beam and column, then we have define option. For the slab, we have a thickness option, and for the steel structure, we have section database option. Okay, like I'm just going to show you the section database options also. So if I click on the section database, a section profile table will open. So from here we have to select our Indian code. Then here we have shape types, like if it is a S shape or I shape, or if it is a type angle or channel, and then we have these values. And for the normal concrete structure, just go to the define and select the shape first. Like if your column is rectangular, so pick the rectangular and provide the rectangular properties. Like I'm just going to provide it YD and Z. Z will be along here. It is so 0.3 by 0.35. And for the beam, just going to provide like 0.23 by 0.23 at of a 9-inch only. Okay. Then yeah, so sometimes maybe I just provide this property and in the last your software will show you the error and all. So then we have to change the property according to the output also. Like the project which I showed before that, here in that particular project, few beams were more than of 6 meter length. So their depth was increased up to the 0.5 meters. Okay, and default the architect which provide me that value, it was like 0.3 by 0.3 only, but the length of the particular beam was up to the 6 meter, and soft in the concrete design that particular beam was getting failed, and in last we have to change that the depth of the beam up to the 0.5 meter. So the software will show you this type of errors and all if there is any property error or if it is over reinforced, then also software will show it. Okay, so either we have two options, either just reduce the reinforcement detailing, and still if it is getting failed, then we have to increase the concrete values. Okay, now this will be assigned to the column. So we have front we have different views here, so I will arrange it in the front view. Then I can select the column by this option also, like this. Don't select the beam. Whenever I create a rectangular option, you have to create it, select it through the column, this also. Or we have a select menu option also. Go to the select menu, and under the beam panel, we have parallel option. So parallel to the y axis, so all the beam which is parallel to the y has been selected directly. And then after selecting this, we have assignment method. So most of the time we will use assign to the selected beam option, because yeah, so we have total four types of assignment method. Let me explain this. If I click on assign to view, then all the beam and column will get the same property. But here in this project, we have different properties for beam and column. That means assign to the view option will not use here. If our structure have same property, then we can use it. Okay, assign to the edit list means we have to add each beam number one by one. And you know that here we have total, go to the geometry, let me say sheet. Here we have total 255 members. So, and exactly we don't know the exact member number of beam column. So using this method is also very difficult. This can be this option will only use if we are after analyzing and all, if we have any change in our structure, or we have to create one or two other members, then we can add that particular member numbers here to assign the property. Use cursor to assign means we have to click on each cursor, each member one by one. This will also take too much time. So the simple thing is assign to the selected entities. If it is called, if it is beam, yeah, if it is your member, then when we have selected beam options. And this option will highlight only after selecting them. So go to the select menu, beam parallel to the y. Now it is visible, then assign it to the beam. Sorry, it happens last time I just click here, that's why I have to click one more time here. Now assign it. Okay, select let y, assign to selected, then assign. Yes, it has been assigned. Okay, next thing here, that is for the beam. So beam are parallel to x and z, then assign it to the selected. Yeah, let me save it, because I will reopen the software. Okay, so here it was. Now after this, next thing is support. So create a support. Go to the create. Here we have different type of support options: fixed support, pinned support, and fixed part. We don't have a roller support option here, because along which direction we have to release it, we don't know. That's why we have to define it through the enforce part. And defining, you have to select the, we have to select the release axis, like if it is releasing along, if along the fx, that is the translational direction, or along the rotational direction. According to that, we have to select our axis of release, then we have to define it. And fixed support will be fixed along all directions. That means along the translational direction and along the rotational direction also. Then add it, then select them and add it to the bottom nodes, assign to the selected nodes. Okay. Hmm. Okay. Then after assigning this value, next thing is loading. Actually, in this project, material properties is showing here also. ये written में आ रहा है. I just want to hide it. That's why I just reopen, but still it is showing. This is not a problem, but sometimes we get irritated by showing all these values. So let me hide it. Labels, then material, load and scale था. Here, release, port. Display option. It happens sometimes, but not always. Not getting the exact diagram. Well, I will hide it later because we have very less time. I have to do the other things. So let me continue first. Either one more thing. No, okay, so continuing. So after adding the support and all, our next thing will be loading. Okay, so here I'm just going to add dead and live load only. So for that, we have to pick the load case detail option first. So go to the load case details and click on the add. Then loading type will be first dead. Then we have to provide its title. Providing this title means everyone can see the direct load names. If I don't provide the title, then we have to open this value and we have to check out which type of load this is. That's why we have to provide its title name. Okay. If I don't provide the live LL, that is the live load, then we have to see it like, let me provide anything. Here it is. Then after that, we if we have to select I don't know, is it is a live load or any other thing, so we have to select it, then click on the edit. Then from the loading type, I am able to understand that it is a live load. That's why provide its name according to the loading type. Now under the dead load, we have to provide self weight. So self weight direction, due to the gravity, it will be towards downward direction, and that's why I provide the factor value to the minus, and one will provide the uh, loading factor values. Like if I provide the factor value to the -2, that means two times of the dead load, two times of dead load will be applied. So here I will add only the exact value of load type. That's why I will add it one value. Okay, and direction y, that is along the, you know that here along the due to the gravity, here we have the y of the y axis of it. Okay, so that's why we have to put the y axis here. Then click on add. So self weight has been defined. Okay, and we have a question mark option here. That means we have to assign it now. So to assign it, we have to click on self weight, then click on assign to view here. Again, we have we have assignment methods, different type of. So self weight will be assigned to the complete structure. That's why I will assign it to the assign to view option. Okay. Now next thing will be, we have to add the brick masonry unit load also, because our this structure here right now, you can see we have only structure frame. That means we have only beam and columns here. Okay, now we have to create the wall also here. That means we have to calculate that wall load also. So to calculate the wall load, we have a formula, that is the unit. First thing will be the volume multiply by unit weight of material जो भी आप use कर रहे होगे. So volume will be for 1 meter. So if I provide it for the 1 meter length value, so volume of the wall will be wall height multiply by wall thickness multiply by wall length. So we are going to calculate it for the 1 meter length value, that is the per meter per length value. Okay, so we have to add only the wall height, that will be 3 meter, wall thickness, that is if your wall thickness is of 115 mm or 230 mm, so you have to pick according to that value, that will be 0.23 meter or 0.115 meter, and length will be 1 meter. So your formula will be 3 multiplied by 0.23 multiplied by 1 and multiply by material unit weight. अब material क्या है आपका यहाँ पर? Here we have brick masonry unit value. So for this, now according to the material, according to the masonry composition and according to the size of brick and brick materials, that this value will vary in between 15 to 20, sometimes 22. So I'm just going to add a value of 20 here, that will be the brick masonry unit weight. Okay, so when you calculate it, you will get approximate value of 13 point something. Okay, so and if your beam, if your wall is of 0.115 point, yeah, or we can see 115 mm thickness or 100 mm thickness or 110 mm thickness. So according to that, we have to calculate it. So here I'm just going to add a round off value of 13 mm. So for that, go to the dead load value, and this wall will be created on the beam only. Okay, so that's why we have to add it through the member load. So I will click on the add and I will pick the member load here, and I will provide the member load value to minus 13 kilonewton along the GY. Now we have to select all members to add this value. So I will select the member which are parallel to X and Z, because wall will be created on beam which is parallel to X and Z only. So for that, we have select menu again, go to the parallel X and Z here. Now assign it to assign it to the selected beam and click on assign. Minus sign will show the direction of the load, and due to the gravity, it will be towards the downward direction. Next thing, here we didn't create the slab. Okay, but you know that on our structure there will be slab also. That means if we didn't create the slab, so using the self-aid command, slab load is didn't add here. That means we have to calculate the slab weight manually, and for this again the formula will be same, unit weight of material multiply by slab volume. And for the slab we have to calculate this value for the per meter square area. That means length and width will be 1 meter each, and the thickness value, if our slab is of 150 mm thickness, so unit weight, let me calculate it, length 1 multiply by width 1 multiply by slab thickness, that is the 0.15, and multiply by the unit weight of concrete. So you know that for the M25 it will be approximate 24 point something value. So I will round out it to the 25, and when you calculate it, it will be approximate 3.75 kilonewton per meter square. Okay, so that will be the floor load because it will be assigned on the each floor. So we will add the weight of slab under in the dead load through the floor load. So go to the floor load here and put the pressure value to the minus 3.75. Let me explain one more thing. Here we have value kilonewton per meter square. That means we have to calculate the pressure value for the 1 meter square area because it is meter square. Okay, and under the uh, on the member load it was kilonewton per meter. That's why I calculate it for the 1 meter length. For the beam, for the we can say for the wall load, I calculate it for the 1 meter length. You can see it here also kilonewton per meter. That means we have to calculate it for the 1 meter length, and here along the plate it was meter square. That means we have to calculate it for the per meter square area. That's why length and width I put the value 1, and I provide the thickness value here. I think it is clear to everyone now. Then we have to provide the floor range. That means from which floor you are going to add your plate and up to the which height. That means, so if I put the 0 here and y value will be up to the maximum height, that was 18. So I provide the value more than 18 will not affect your output. I will just put the value 18, but I just provide the minimum value to the 0. That means it will be start from the 0 at the bottom, but software here, but this software know that here we don't have flow here. That's why it will not add it on the 0 meter height. You can see it when I click on the add and close it. You can, and I pick it, you can see the flow load is generated from the first floor. Okay, yeah, if we create the beam here also, then it can be added here also. After the dead load, next thing will be our live load. So go to the LL, and under the IS 1875 code values, you know that we will get the live and dead load values also for the different type of structure. Like under the live load, if it is a residential building, so live load will be approx 2 kilonewton to 2.5 or 3. But in case of a important building like your school, college, hospital, it will vary up to the 5 kilonewton and all. So all these value will be, you will get according to the IS code. आपको सारी values वहां से मिल जाएंगी. So here I'm just going to add the live load for a general building. So I will add it of 2.5. Minus sign will show the direction here, and again flow range will be 0 to 18 meter. Add it. Now we can add load combinations also. We have to add it according to the IS code. So for this, even if you want to define combinations, you can define it also. So, and if you want to add combinations according to the IS code, just go to the auto load combinations and select the IS 456. Here it is. Then click on generate load. So these are the load combinations generated using the dead and live load only. If we have wind load and earthquake load, then combinations according to that will increase. Okay, so then click on add. So these are the combinations according to the IS code. Now we have to analyze our structure. So go to the analysis and provide the analysis command using the analysis command option here, and click on all. Basically what you want to print in the output will be affected by this. So no print means it will print the minimum data. Load data, it will print the load data only. If you click on the all, so it will print the maximum data like node displacement and all everything. So I will add it. So when you click on the all and add, you will see a performance analysis print all command has been added. If you don't add this command, software will give you error. Okay, after providing this command, next thing is run your analysis. So this is your primary analysis. Up to this point, you will see only load and response of the structure. We don't have the concrete design right up to this point. We have to do the second analysis for that. So what you will get here? You will get the summation of the load and all, like total dead load was, here it is, actual weight of the structure, and all software will calculate it according to the load, because I add the dead load was the structure of the sorry, it was your structure's weight. I provide the brick wall load, slab load, and self weight, and software will calculate the total weight of the structure. And due to this load, what is the maximum and minimum displacement at which node? Everything will software will show you. I'm seeing it in the here. Okay, let me show you. Okay. Total applied load, total reaction load, total applied load 2, that is the live load and all. आप इसको यहाँ से देख सकते हो. But to see it in a graphical form, you have to go to the post processing and add it. So here we can see the reaction value. This reaction value at the bottom will help out you to create your foundation. Okay, then beam result, that is the safety, that is the bending moment about z axis, bending torsion forces about x axis. You can see here also. Let me show the, okay, like this. Even you can see the axial forces. This one also. We don't have plate here, so that's why we will not able to see any plate here. After this, we have to do the concrete design. So for the concrete design, go to the electrical modeling again and go to the analysis and design, then concrete. I'm just going to change the unit according to the IS code, because under the uh, IS IS values we have either change it or not. That depends upon you. I'm habitual to do it in the mm and Newton. That is the secondary analysis. So if you don't change this value, then that means you have to provide this value for the kilonewton and meter. Okay. So go to the design, concrete, pick the ISO 56 values, then go to the defined parameters. So here we have FC value. I just change it to the Newton per mm square. That's why I have to provide value according to the that. If you pick the kilonewton per meter square, then you have to provide the value 25,000. Okay. So that is the FC value. So you can add these value according to your requirement. Okay. So FC value will be Newton Fy main, that is the yield strength of the main reinforcement bar. So the current values are like 550 or 415 was the later version, but right now we are using 550D and 500. So according to that, I will add this value. Fy secondary means yield strength of the shear reinforcement, that is the stirrups जो आप यूज करोगे stirrups की वैल्यू, like I will add it to the 550 again. Fy main, sorry, max main, that is the maximum size of main reinforcement bar. So in the concrete design, basically we provide range. In between that particular range, software will check these values. Like I minimum size I will provide, like I provide the maximum size of 20 mm, and min main I will provide 12 mm. That means software will provide value in between 12 to 20 mm only. Okay. Same max secondary, that is for the stirrups. So stirrups mainly we use of 8 mm, but we will add the maximum size up to the 10 mm and minimum size mean secondary to the 8 mm. So software will either pick it for 8 or 10. Mostly it will pick the 8 mm size. Okay. Ratio, that is the maximum percentage of longitudinal reinforcement allowed. That means along the column, you know that there will be up to the 0.2 to 4% 4% volume of the your reinforcement bar in a column. So that is the maximum allowed value to the 4%. But mainly most of the time, it software will calculate it under the 1 and something value. So that is all. Like I want to say, what is the ratio? I'm explain again. If your column volume is 100 meter cube, okay, so maximum reinforcement will be up to the 4 meter cube. Okay, it will not increase more than 4 meter cube volume. Okay, that is the volume of reinforcement. Okay, that means we can see the steel bars of main reinforcement plus stirrups. Okay, but mainly it will comes under 0.2 to 1.5 something. It will be according to the load and all. Now we have to assign these all these value to the assign to the view. Yeah, so it will take only 1 to 2 more minutes to do the concrete design. So we will add all these value to the assign to view. Right now we are doing all these things using the RCDC also. So STAAD Pro, we have to apply load and all through the STAAD Pro, and concrete design, slab design, everything now is we are doing on the RCDC. So design beam and column. We don't have slab here, so don't need it. And takeoff will provide a tabular report of the concrete and weight of the steel. So we have to add it also. And for the design beam, we have to select the all beam which is parallel to X and Z. So again, that means we have to select the beam only. So same thing, we will pick the beam parallel to X and Z. Then design column, it will be parallel to Y. Takeoff will be assigned by automatically. Now we have to run the analysis one more time. Go to the analysis and design and run the analysis. So we are getting 10 warnings. So let me find out the warnings. Yeah. So it is going to fail for the beam number 49 and saying section fails while designing sections 0. Okay. No bar is available for the reinforcement. So we don't have the output for this. And column में क्या है? Let me see it. Columns 12 dia के आपके पास. Here we have 12 dia 4 bar equally distributed, and tie reinforcement are 8 mm at a spacing of 190 mm center to center. So go to the properties, rectangular, me edit it like point 250 by so with 3 था, sorry, इसको मैं 250 समथिंग मैंने इसको चेंज किया. Let me reanalyze it. Okay. So for that particular beam जिसके लिए भी fail हो रहा था, now we have to increase section size and also you will get 0 errors here. And now beam design also you can see. So this software will show you output in two forms, like it will show the summary of reinforcement area also. Most of the structure software show you the reinforcement area only. Then we have to calculate it manually, but the software STAAD as an option, it will show you the bar size and number of bars also. Okay. And sometimes we didn't satisfy by the software's bar distribution procedure, then that's why it will give you the reinforcement area also. That means we have to calculate it. We can calculate it manually also. Okay. And also if I click on any beam, so it will show you the concrete design shapes also. If you click on any double click on any column, go to the concrete design, it will show the bar reinforcement shapes also. And to see the CAD file, that means the reinforcement detailing file, we have to analyze it on the RCDC. We have to transfer our model to the RCDC, then next further detailing will be done on the RCDC now, because now we don't have RC designer in the STAAD Pro. Before the RCDC introduction, जब से आपका RCDC introduced हुआ है, we don't have RC designer here. And before the RCDC, we have a RC designer option in the STAAD Pro, by which we can create the CAD files of AutoCAD files of the reinforcement detailing also through this software. But right now we have to do it through the RCDC only. So if you have any question, any doubt, you can ask, because here we will take a 15-minute break, then we will continue in the second half.